Problem 4. A three-dimensional rectangular box with dimensions x, y, and z. So let's first draw it out. We have a three-dimensional box that looks something like this with x, y, and z. Has surface areas whose areas are 24, 24, 48, 48, and 70, 72 square units respectively. What is x plus y plus z? So obviously we know that x times y gives 24, right? And it doesn't matter what you assume. It could be y times z. It just has to be distinct. We can do x times y is equal to 24, y times z to equal 48, and we also know that x times z would give 72. Now, you can swap all these numbers for all you like, but ultimately you'll get the same dimensions because if you swap the numbers, it just rotating the cube in different ways. So it doesn't matter how you assume it, just make sure you have these distinct combinations of x, y, and z together. Now we have three variables and three equations, therefore we can solve for each variable. Now, how do we do this? Well, let's isolate everything in terms of x and z. With these two, we know y is equal to 48 divided by z. So therefore, x times y becomes x times 48 divided by z gives 24. Right? And what is z equal to? Well, z is equal to x times 48, right, divided by 24, which is the same thing as 2x. Therefore, if we plug it into the third equation, we get 2x squared is equal to 72. Now, x squared will be equal to 36, so x will be equal to plus minus 6. But obviously, a side length cannot be negative, so we know that x is equal to 6. We have a first side length, so everything else comes naturally. Y is 24 divided by 6, which is equal to 4. And what is z? Well, z is 72 divided by x, which is 12. So z is 12, y is 4, x is 6. What is the sum of x, y, z? Well, that's 22. So your final answer would be answer choice B.